Hello and welcome to the course of Computer Network. This lecture is in the continuation of our last lecture, which is all about RDD 3.0 version. We have already discussed RDD 3.0 version in our last lecture. Today we are going to see that particular protocol in action. So this RDD 3.0 protocol is a completely reliable protocol, which is also called a stop and wait protocol. Here you see this RDD 3.0 sending side, uh, which we have already discussed in the last lecture. Today we'll see this particular protocol in action. So we have four cases in this particular protocol. You can see the first case is no loss, which means there will be no loss during the transmission of the packets. The second case would be packet loss. There will be loss of packet during the transmission of packets. And the third case would be there will be loss of acknowledgement during the transmission. And the fourth case would be premature time out of our timers. So let's see the first case, which is which has a sending side and a receiving side, and packet number 0 is ready to get transmitted from the sending side. You can see sending side transmits packet number 0, which is received by the receiver. Then the receiver will send an acknowledgement for this particular packet, and this particular acknowledgement is received by the sender. Then only this particular sender can send the next packet. It is sending the packet number 1. It is received by the receiver. It is sending its acknowledgement back to the sender. Now again it is sending the next packet with the sequence number 0. It is received by the receiver, and this particular receiver sends acknowledgement back to the sender of packet number 3rd, which has a sequence number 0. So this particular case has three packets: first, second and third, which has got the sequence number 0 1 0. So there is no loss in this particular case. Now we see our second case, in which there will be a loss of data. So sender sends a packet to the receiver. Receiver receives this packet, uh, uh, create an acknowledgement for this particular packet, and sends it back to the sending side. And now you can see sender is sending its next packet with the sequence number 1, and this packet is lost during the transmission. So what happens? Your timer times out, and after time out it will retransmit the packet of this particular sequence number. It is received by the receiver, and it sends back the acknowledgement of this particular packet back to the sender. It is received over here. So that is how these two cases are there in action of RDD 3.0. Now we see our next slide, in which we have two more cases of RDD 3.0 version. The first one is if our acknowledgement gets disappeared during its journey. What will happen then? Let's see. Sender sends a packet number 0. It is received by the receiver. It sends back its acknowledgement to the sender. Now sender sends packet sequence number 1 to the receiver, and here you can see receiver creates acknowledgement for this, and sends it back to the sending side. But you can see there is a loss of acknowledgement 1. So what happens in that case? Again, what will happen at the sending side when it will not receive the acknowledgement? It will assume that its packet is not received by the receiver, and once uh, timer is out, then it will retransmit the packet again. But here you can see receiver detects this particular packet as a duplicate packet only because of the sequence number. The packet sequence number is 1. but it is expecting sequence number 0. So that is why sequence numbers which we are using in this particular protocol 0 and 1, they are helping this particular protocol to detect the redundant or duplicate or retransmitted packets. So you can see in this particular case of acknowledgement loss that at the receiving side a duplicate packet is detected and which will be deleted afterwards. So that is how this particular protocol works and provides you reliability. Now the fourth case is premature timeout or delayed acknowledgement. We'll see what it is. Sending side sends a packet to the receiving side. It sends back the acknowledgement of that particular packet. Now sending side sends next packet to the receiving side. Receiving side receiving side sends back the acknowledgement, but due to some problem during the journey, it might have high traffic, or there may be some delay due to the queue at the routers, or anything can happen, and acknowledgement number 1 for packet number 1 is not received by the sending side before timeout occurs, and once this timeout happens at the sending side, it will retransmit the packet, but again this particular packet will be detected as a duplicate packet because receiving side has this particular packet already with the sequence number 1, and once this receiving side receives this particular packet, it deletes it after detecting as a duplicate packet, and this particular protocol will flow normally. Over here you can see when this particular acknowledgement is received by the sending side, this time it will send the next packet with the sequence number 1. So that is how it works, and it works perfectly alright, and it is a completely reliable protocol, and it is also called a stop and wait protocol. Because of this particular protocol doesn't provide you proper utilization of the channel, which you can see over here. The performance of this RDT 3.0 version is calculated with the help of utilization. This utilization of sender is this, as we all are aware about this thing. This is a D transmission delay, which is all about L by R, which where L are the number of bits present in a packet and R is the transmission rate in bits per second. So fraction of L and R. Transmission delay is all about length of a packet in bits and transmission rate. So it's all about L by R. So transmission delay of a particular packet is 8 microseconds if in that particular packet has 8,000 bits, and this is the transmission rate 10 to the power 9 bits per second. So this is the transmission delay. Transmission delay, I'll explain you once again. Transmission delay is all about number of bits present in a packet and transmission rate. It exactly means time required by a node or a router to push all the bits present in a packet into the link is called transmission delay. So time required by the router, this time is L by R, and your utilization is all about fraction of time sender busy sending the data. So this is all about your transmission delay divided by round trip time plus that delay during the time your sender is sending the data. So this is the at the bottom You will at the denominator you will find the complete time during the sender is busy, and this is the actual time when sender is transmitting the data. This is the transmission delay, and this is the complete sender's busy time. So the fraction of this will get you the utilization, and you can see over here that utilization is 0.00027. So you can understand this particular thing with this particular diagram, where you can see sender is there, receiver is there, first packet bit transmitted at t is equals to 0, and this is the time required by the sending side to transmit all the bits into the link. You can see this is the time which starts from this point to this point. This is called L by R, and this is the time from this point to this point. That means at this point, uh, uh, this is the time required by this particular link to, and once your data is at the receiving side creates an acknowledgement, and it sends back the acknowledgement back to the sending side, which you can see over here. So this much time is required by the receiving side to send the acknowledgement back to the sending side. So from this point to this point, this time is called RTT, which stands for round trip time. Round trip time means sender sends a packet to the receiver, and receiver sends back the acknowledgement to the sending side. That means a round trip is completed. So RDT for this stop and wait protocol is this much amount of time. So during this time, sender is actually transmitting the data, but from this point to this point, sender is idle and waiting for the acknowledgement. So this happens in this stop and wait protocol, and this is the time which is wasted by the sender. And during this time, sender can keep on sending their next packets, but it doesn't happen in stop and wait protocol. So the utilization of this particular stop and wait protocol RDD 3.0 is transmission delay divided by the complete time, round trip time, plus the transmission time. So this happens, and this will come out, which is very less if you compare it with the advanced reliable protocols, which we'll see in our coming lectures, which are completely based on the pipelined funda. As you can see over here, in the next coming lecture, we will discuss these pipeline protocols, in which sender keep on sending the data without waiting for the acknowledgement, but there is a limit of sending the data without waiting for the acknowledgement. So that we'll see in our coming lectures, how we can improve our reliable data transfer protocol, and how we can increase the utilization of this particular protocol. So see you in the next lecture. Take care.